So now we're going to go ahead and look at uh, the first type of solid, which is a solid of a known cross-section or of other cross-sections. These are typically given to us in words. It's rare that we're given a graph, but we are occasionally given a graph, but we still have to figure out what the shape is supposed to look like. So the region between the x-axis and one arc of y equals 2 sine x forms the base of the solid. So I graph 2 sine x. I know it starts at the origin, goes up, and comes back to hit the x-axis at pi, x equals pi. And each cross-section is a semicircle perpendicular to the x-axis. So that means I'm going to be sticking a semicircle perpendicular to my x-axis such that the diameter of my semicircle is this distance from the x-axis up to my curve. And that we're trying to picture this semicircle is coming out at us. And I'm going to do this with an infinite number of semicircles. So I could have put a semicircle here. I could have put a semicircle here. I could have put a semicircle here. This is a lot harder to kind of draw the full shape. So kind of what I've sketched on the graph is what I would mean by the step of sketch the solid. Then off to the side, I'm going to draw one cross section. So I have a semicircle because they tell me that's the shape of the cross section. The only dimension I know is that the diameter has to be whatever my function is, because I go from the x-axis up until I hit the curve. So my diameter is y. Well, the area of one semicircle is pi over 2 r squared. Well, my radius is going to be half of y. So I have pi over 2 times 1/2 of y squared. But I'm told that y is 2 sine x. So I have pi over 2 times 1/2 times 2 sine of x squared. And then if I simplify this, because remember, I don't have to simplify, but it's nice to do a little simplifying if I'm going to use this, and I am going to use this. I get pi over 2 times sine squared of x. But that's the area of one cross section. I need to accumulate all of the cross sections. And in calculus, the thing that accumulates is the integral. So I need to accumulate the integral of pi over 2 sine squared. So I'm accumulating all of my cross-sectional areas, and my x's are going from 0 to pi. I do need to use a calculator for this one here, and I get that my volume is 2.467. If it helps, I am able to demonstrate kind of what this looks like. So here I have a graph of 2 sine of x. We're looking at this region right here. I want to use semicircles to build it. And I'm going from 0 up to pi. And I want to add more and more and more and more semicircles. And as I add more semicircles, I can start to get a sense of what this looks like. So I'm going to go up to 100 semicircles here. Now if I move it around, I can see what shape I'm getting.